In this example, I'll be showing you the digital collaboration between the Rockwell softwares E3D, Studio 5000, and LogixEcho V2. In this video, you'll see how the software works together to emulate not only the device and panel functionality, but also represents how a system integrator would be able to utilize these features to perform system validation by testing and troubleshooting their logic in real time using virtual commissioning. As you see on the screen here, we're utilizing the wiring diagram catalog from within E3D to build a digital twin of a Rockwell generic standard panel, which will be used to connect the virtual components directly to the PLC. Now, if I were to open up a panel and then also open up a set of standard prints, you will see that when comparing the two, you'll see that the virtual power and communication are wired to the exact inputs and test outputs as you would see in the supplied prints, and as well as the panel dimension properties. From a component perspective, the front of the panel, and focusing on the HMI panel, consists of multiple push buttons, selector switches, e-stop, a stack light, and then also an HMI. To note, this particular demo utilizes FactoryTalk Viewpoint for the HMI interface, but could also handle any web-based applications such as FactoryTalk Optics. Now, if we were to look at the back of the panel, you will see, and to give a proper representation of the demo, you'll see that the components that would normally be located on the inside of the panel are mounted on the back. And these components consist of two circuit breakers, a Rockwell 1791 ES IB16 module, and also a switch. Now, to give a deeper dive into the connection between E3D, the PLC, and Studio 5000, you'll see that I'm utilizing LogixEcho V2, which gives me the ability to use a emulated GuardLogix 5580 processor. And then going back into E3D, looking at the I/O browser, the PLC program we're utilizing in this demo consists of a generic tag structure, which can easily be used to replicate any additional panels if needed for any virtual system that we were trying to build. And you can see to the right here, these are all the tags that have been linked over from the running PLC and are directly connected to the components being used in the panel. And by clicking this drop down right here, you can see that we have the ability to link up any tag that can be found within the PLC. And then as far as the established handshake goes, so the handshake between the PLC logic and E3D, if we were to open up the PLC program that we're using, you can see that we're online with it. And then to take a quick look at the I/O tree that's found in the controller organizer, you can see that because we're using LogixEcho and E3D 2023, we're able to establish that class 1 connection with the emulated components, allowing us to perform a system validation without having any physical components present here. Now, to go back to show how the tags are linked, going back to E3D, you can see that we have the linked inputs and output tags, which are reading and writing directly from the PLC. But to look at it from a input perspective, if we were to hit the e-stop, it toggles the linked PLC bits. And then if we were to go to the wiring diagram, restart that so you can see that it shows all the class 1s. If we were to go look at the wiring diagram portion of this, focusing on the block, hitting that e-stop, it's also showing the toggling right there as well. And that's because of the wiring diagram, the inputs are linked directly to that 1791 module, which are writing directly to the PLC and can also be seen from the PLC side. But from a output perspective, if we were to toggle a bit within the PLC, let's move that down so you can see that better. You can see once we toggle that from the PLC logic, you see that E3D is reading that PLC value and is triggering that output. And that goes with all the other I/O as well. So, and then if we were to take a quick look at the 1734 panel, and we can go back to the I/O. Actually, we'll go back to that panel itself. Focusing on the block here, if I were to go into the PLC and toggle a bit for that, you can see that the output is actually writing that cint value of 32, which is going to the output 5-bit here. And then same with the push button. If I were to press that, it's giving that other value. So, so just to recap, having the ability to connect directly to the emulated PLC and to utilize E3D's ability to create standard panels, it gives us the capability to perform a level of virtual commissioning, thus giving us the opportunity not only to validate, but also alleviate any logic or wiring issues before starting up the physical equipment. I hope you found this demo helpful, and if you have any questions or would like to explore more wiring diagram examples, please feel free to reach out to me directly at mbruner, B-R-U-N-E-R, at ra.rockwell.com. Thank you.